Hey, my name is Tim Rancorn. I'm the host of a paranormal technology show called Tech Time. You'll find Tech Time on paraconnersnetwork.com on Thursday nights at 7 o'clock Central Standard Time, 8 o'clock Eastern Standard Time. What Tech Time is about is actually paranormal technology that's used in paranormal investigations. I try to use the scientific research as far as to try to obtain credible evidence. And as you can see with this layout on the table here, I'm always trying to find new and unique equipment. Stuff that I build myself or ideas and suggestions that I obtain from other people. Especially a lot of great minds in the field that have mentored and actually motivated me to the scientific side of the paranormal research field. What you're seeing here today and what I'm trying to create is actually a EMF emitter. To break it down, why I'm trying to create an EMF emitter is I am trying to start in the beginning of proving one simple theory, and that theory is the fact that EVPs, electronic voice phenomenon, is actually EMF voice signatures. So, on the road of the path of trying to convince people of that theory and share my knowledge with everyone that I come across, especially y'all guys watching this clip, is trying to prove to you the significance of electromagnetic fields and its presence and actually its effect as far as disembodied voices. Because you have to understand one simple fact. If you believe in disembodied spirits or ghosts, or my favorite term, shadow dudes, you have to understand that these unique individuals do not have masks. They do not have vocal cords. They do not have anything to be able to project sound through masks. So I guess your question is how do they communicate? And how do we obtain voice evidence like EVPs or AVPs, which is audio voice phenomenon? Well, my answer to that is that I believe that disembodied spirits actually emit what we call an EMF voice signature. Now, EMF voice signature is a band of energy that actually emerges. They can emerge anywhere. It doesn't matter. That's why they're so hard to record. But that emergence of EMF energy actually causes a wave of energy that is magnetically based, and it resonates on things like what I'm showing here is actually a inside of a speaker. The speaker, as you can see, this little lighter color piece right here is what you call a diaphragm. There used to be a little inner diaphragm right here, but I actually have cut that out, and I'll show you why later on. But if you see the little shiny substance right here wrapped around the edge, right here, that is a copper wound coil. Now, this copper wound coil is very sensitive to electronic pulses, and it's also very sensitive to electromagnetic fluctuations. So now that you've seen the guts as far as this speaker itself, let me show you a little clip as far as exactly how a speaker works so you can follow me along once I put this sucker together. Okay folks, what you see here is the actual demonstration and a diagram of the inner works of actually how a speaker works. And from this particular picture, you can see that what you have here is the actual speaker wire that's coming into right here. You can see speaker wire, and you can see it variating as far as positive and negative charges. Now, that is the actual electronic impulse coming from the transmitter radio that's feeding into the speaker itself. And this negative and positive charge is feeding into the copper coil right here. And as you can see in the copper coil, is surrounded by what you call a spotter, which is basically like a shock absorber for the speaker itself. And right here, this big black object, as you can see labeled, is the magnet. Now with this varying positive and negative charge, what it does is it changes the polarity of the magnet itself, causing this copper coil to excite. And as you can see in this little diagram, it jumps up and down as the change in polarities as far as the speaker wire. And there you have your shock absorber, which allows the voice coil to pop up and down. And what this actually causes, this excitement of going up and down, this is your diaphragm that you can see. It's basically cut in half. This diaphragm, actually impacts on the air itself, and when it impacts the air with this excitement of the voice coil going up and down, this is actually what causes the sound wave itself. So, as you see, you have your suspension with the diaphragm right here. This is the gasket holding the overall components, and everything's pretty well labeled here. So this is your internal guts of actually how a speaker works. You have the positive and negative changes in polarity, the plane of the coil itself, which causes it and the change in polarities to go up and side down because of its relationship to the magnet itself. And that excitement, which I would have to say between this changing up and down, it probably happens a heck of a lot faster than what it's showing you here. But those pulses of it going up and down, impacting on the air, causes the energy of the sound wave. And that's actually where you're getting the noise from the speaker itself. So, I hope this diagram kind of gives you somewhat of an idea as far as how this works. And I obtained this information from howitworks.com. Hey, go figure. You can look for itself and read all kinds of cool information about how things work. But, there's your explanation as far as how a speaker works. Okay. Now that we have a little bit clearer understanding as far as how a speaker works, then you kind of understand what I have in my hands. Now to further explain what I have in my hand, I obviously called it a speaker, but a speaker of what? Doesn't look like the normal speaker that you find at Radio Shack, but that's why I have this big cone here. I guess you can recognize this. Whoops, I knocked over the cone itself. But this actually is a dynamic megaphone. And what I did is I basically stripped the guts out. Yes, I cannibalized the dynamic megaphone to put together something new. And this is the interior speaker guts of that dynamic megaphone, which I showed you the internal parts of it as far as the wound copper coil. Now, what came actually with the speaker itself is this magnet. And this magnet, and I'm going to line my holes up to make sure that they're where they're supposed to be, like this. Move around, okay. Now the copper wound part of the speaker fell into the little groove that I showed y'all. And now the only thing I have left is to line everything up. Put my screws in, of course, which is not a hard thing because there's a magnet drawing them in. Get my holes lined up. Alright, now that I've got everything tightened down, this right here is a regular radio boombox. And kind of serves its purpose. I like to start out with kind of a low frequency so I don't blow anything up. But it's only about, I guess, 30 watts. You know, gives plenty of power for what I'm trying to demonstrate here. And this is actually the speaker wires to one set of the speakers that's hooked to the back that I've clipped and, you know, basically pulled off the thread. And what I'm wanting to do is hook both of the speaker wires to the two. Alright. The other two tools that I have here, this is your, you know, average everyday Tesla EMF meter, and this is your cell sensor. Comes with a nice little probe so I can get pretty close to it without banging into it. I'm going to show you readings off of both of these EMF testers to kind of show you the fluctuations as far as the wavelengths once I actually turn the radio on. Now, first I'm going to turn it on, and I picked out a talk show on the radio. The reason why I picked out a talk show is because you'll have dead intervals instead of just continuous music. That'll give us the fluctuation we need to see whether or not there's any excitement in the EMF emitter, showing the variances, you know, of whether or not the energy, the positive and negative current, is actually exciting the coil up and down. If it's exciting it up and down, well, then you'll see variations in it. But right now, if I turn the meter on, you're going to actually pick up some EMF signature off the magnet itself. And as you can see, it's just consistent. There's no variations to it. Now what I'm hoping is that once I turn the radio on, first I'll show you that I'm actually on a talk show stereo station, and then I will unplug this speaker to where we don't have any noise interference at all, and we'll see if there's variations on the EMF emitter that I've just built. Okay? Alright, we're going to turn it on.
And now we can help you. Call 800-838-0565 to see how this powerful nonprofit program can work for you. Get free of credit card debt today. Call 800-838-0565. That's 800.
I'm going to turn on the cell sensor, and we're going to see if there's any variations. You hear the voice coming through the radio, and we're going to see once we get to a top point and there's some deadness into it, we'll see whether or not there's any kind of variations. Alright? You can see for yourself.
We move forward, so does the rest of the economy. CSX trains are the most cost-efficient way to move goods to market. CSX, how tomorrow moves.
When it comes to managing your diabetes, Bayer's new Contour Next EZ blood glucose meter makes testing easy. You also get exceptional accuracy because it uses the next generation Contour Next test strip for close to last test results. And all this at the lowest everyday price of all major brands. You can find Bayer's new Contour Next EZ meter at your local retail pharmacy. Just ask your pharmacist and upgrade today. Bayer's new Contour Next EZ meter. Ease, accuracy, and